There are a lot of different ways we could attack this one. There's a 10 and a 5 here. We could go 5 and 2. We could take our 3 and our 30, which would give us 1 and 10. We could take our 9 and our 63, because 9 goes into itself once, and 9 times 7 is 63. 2 times 1 is 2. 7 times 1 is 7, and that 7 times 10 is 70. This fraction could be reduced. They're both even. 1 and 2 goes into 7 3 times with 1 left over. 2 goes into 10 5 times. Back here, we could have actually used the 2 and the 10 and further reduced this to 1 and 5. If we had done that, would have been 1 times 1 times 1 is 1, and 7 times 1 is 7. 7 times 5 is 35. If we had reduced one more time, we could have simplified this even more. As it was, we missed that on the first time, but the reducing step was caught at the end. Wow, look at this one. What can you see here? I do a 27 and a 9. 9 goes into itself once. 9 goes into 27 3 times. We could take the 16 and this 8 way over here. There's the numerator and the denominator. So 8 goes into itself once, and 8 goes into 16 2 times. How about this 28 and 4? They're both even numbers, and they're both in the sevens line, and it's in the fours line too. So 4 goes into itself once, and 4 times 7 is 28. So 4 divides into 28 7 times. Is there anything I can do to 15 and 9? Well, they're not even. They both don't end in a 0 or a 5, not twin double digits. How about if we add the digits? Well, we know 3 and 9 is going to divide into 9. If we add the digits here, 1 plus 5 is 6, and 3 works there. So let's use the 3. 3 divides into 9 3 times. 3 divides into 15 5 times. Here are the numbers that we have so far. Do we have anything that we can do now with tops and bottoms? How about these two 3's? We have a numerator 3 and a denominator 3. Those could change to 1's if I use divide by 3. So now that's reduced it even farther. 5 times 1, 1, 1. Okay, we've got 5. 5 times 1 times 1 times 1 is 5. And here we've got 2 times 7 is 14, times 1 is 14, times 1 is 14. That long, crazy problem turned out to be 5/14 in a relatively short period of time because you used your reducing or simplifying steps before you actually did your multiplication calculation. That is powerful. It gives you a lot of speed and absolute accuracy because you're working with smaller numbers and because you know your multiplication and division tables.